Hey geometry students, welcome to our first video lesson of Unit 5. Unit 5's big topic is at the top of this page, and it's ratios and proportions. And this is a topic that you've probably interacted with at some point in school or in your life. It's something that most students connect with outside of school. So we're going to do a couple of examples just to kind of like think through where you might have used this in your day-to-day life, and then we'll do some like more formal notes as well. So, the question is, which strawberries are a better deal? I'll zoom in so you can see the full labels from the grocery store. I'm going to pause. I want you to pause the video, think through which ones are a better deal and why. Unpause when you're ready to compare against me. So comparing, the first one is a price for 1 pound of strawberries, whereas the second is a price for 2 pounds of strawberries. Notice LB is representing pounds. So if you want to compare them, right, they have to be the same amount. So one strategy students often do is they'll take the price for the 2 pound option and they'll cut that in half, and that's what I've done at the bottom. And it's $1.99 or so for the 1 pound. And that means that the first deal is the cheaper or the better deal. Another way some students have also compared is they'll take the price for the 1 pound, the $1.49, and they'll double $1.49, and that doubled is $2.98, and they'll say the $2.98 for the 2 pounds is cheaper than the $3.99. So both methods are perfect. Both methods get you to the same place. The second place, where you've probably thought about ratios, proportions, those sorts of ideas organically, is in recipes. So Taiwo has a recipe for chili, and the question is, how much paprika will Taiwo need to feed 3 people, and how much oregano will Taiwo need to feed 7 people? So I'm going to zoom out so you can see the full directions. This is like the chili directions from a recipe. And so work it out, unpause when you're ready to compare. So I've color-coded the work for the paprika and the oregano question. Do notice that this recipe, if you look at the very top up here, it says it yields 6, which means it yields enough to serve 6 people. If you accidentally miss that, maybe pause and try it again. But if it yields enough for 6 people, notice for the green, the paprika, that is wanting for 3 people, so we need to cut the amount in half of the paprika. So instead of a half of a teaspoon, we need a quarter of a teaspoon. The oregano is definitely a lot trickier. We want to feed 7 people, and so we can't do doubling, right? Double the 6 would be too many. So we want to see how much each person kind of gets of the oregano. And each person, if you cut that 1 teaspoon by 6, would get about 1/6 of a teaspoon. So we need that times 7. So it's about 7/6. You can think about it as 1 1/6, however you'd like to think about it. So something that we've been kind of doing here in this example, as well as this, is we've been kind of finding what's called like a unit price. Like a unit price is something that people often use. Like if you're comparing what thing is the cheapest, right? You find out how much per person or per pound, right? So this is like kind of like the unit amount is 1 person has that much oregano. So it's not quite a perfect comparison for the recipe. It's a better comparison unit price for the strawberries, but it's like we're finding the amount per person or per pound, right? And now we're going to do a little bit more formally notes, and this is Unit 5, sorry about that. Unit 5, which is ratios and proportions. And some of the ideas that we're going to do are going to connect really nicely to the warm-ups that we just did together. So I just wanted to find a little quick definition. This is just, I've Googled and I found a nice picture online. And I think it kind of tells us the difference between them, because a lot of times we hear the word ratio, we hear the word proportion. So a ratio is comparing 2 values. Like if you have 12 girls and 18 boys, you could do the ratio of girls to boys in a classroom. And then you can also sometimes simplify them, like 12 over 18 could simplify because they're both divisible by 6. And there are 2 6s on the top and 3 on the bottom. And then a proportion is when you create an equation saying that 2 ratios are equal or congruent, and you know that they're the same in value. So let's try out a couple of little examples here. This is an example with Brookfield Zoo. Let's say that they have 25 giraffes, 32 rhinos, and 542 other animals. So that's not the total, but that's just other animals that are living in the zoo. So I'm just going to pause and total up how many animals there are altogether. Okay, so it looks like there's a total of 599 total animals. I'm just going to keep that on the side just in case I need to use that information. And then they ask us the ratio of giraffes to rhinos. Let's see. So I need giraffes to rhinos, right? I don't know why I did a G for one and the full word for the other. So there are 25 giraffes to 32 rhinos. Another way that we also typically write that is with a colon. Okay. Or some people write it as a fraction, as you saw up above. So there's 3 different ways you can really, write it, express it. One is not really better than the other. I would say it's probably more common these 2 rather than writing out the word 2. Okay. And then part B asks us the ratio of rhinos to the total animals. And this is where oftentimes my students will accidentally take that 542 if you're just trying to go through it quickly and not find the 599 total. So total animals compared to rhinos. So we need 32 rhinos and 599 total animals. And both of these, A and B, I probably should double check that I can't simplify my fraction anymore. But those were looking like they didn't really simplify to me. The 599 is also such a large number, sometimes it's harder to tell if it does simplify. But you would want to double check that it does not simplify. I don't believe these do. The last one says, in Brookfield Zoo, if they were to expand to 2,000 animals, so expanding to 2,000 animals and having the same percent of each type of animal that they currently had. So this is kind of getting at more of a proportion, right? We want to figure out to have a fraction that has the same value, right? If currently like a third of our animals, so per se, are giraffes, we would want a third of the bigger amount to also be giraffes. So let's see. So we're going to do giraffes compared to the total. So currently we have, it says 25 giraffes, and the total is 599. Right, as a percentage, if I did 25 divided by 599, about, it's a very small amount, about 4% are giraffes. So we also want about 4% of our future amount to also be giraffes. So we want something, right, out of 2,000. So there are 2 different options. So option 1 is to do, like I said, and divide and say it's about 4%. Remember, this is the decimal, but you would move the decimal point over 2, or the other way to think about it is multiply by 100 to see the 4.17%. But if I take this decimal and immediately multiply by 2,000, that will find 4.17% of 2,000. So that is one option for how to approach it. So I'm going to do that on my calculator. And it looks like it should be about 83.47. Obviously, we don't have a part of a giraffe, so I would probably round that down to 83, just because it's lower than 0.5. If it was 0.5 or higher, I'd round up. So that's option 1. Option 2 is I've got this pair of fractions that are equal, right? A way to solve for that question mark, if I call that like an x, a really nice way is you do what's called cross multiplying. So you cross multiply, and what comes out of that is I do the 25 times the 2,000. That has to be equal to the 599 times the x. So 25 times 2,000, doing that on my calculator right now, comes out to 50,000. So I'm going to kind of put up here, 50,000 is equal to 599x. And then I just need to solve for x. Divide by 599 on both sides. And my grand total is 83.47, excuse me. So notice you get the same thing either way. So you can either use the cross-multiplying strategy, or you can find the percentage and then multiply the percentage by the total. Either way will work. Okay, continuing on to the next page, remember, always do feel free to pause if you need to as you're watching the video. We're going to look at some examples with some rectangles. So these rectangles, let's just take a look at the side. It says that they're scaled copies of each other. Let's just kind of look at our side lanes and ignore everything else. Notice how the 30 compares to the 15, right? And the 18 compares to the 9. Notice one is double how long the other one is. That's what they mean by scaled copies, right? One is doubling the lengths, right? Depending on which direction you go, A to B or B to A. And so what we would say is that their sides are proportional to each other. And that is an important thing to see, right? If I did something like 30 over 18, the longer side over the shorter, this one longer over shorter, it would be 15 over 9, right? So longer on top, shorter on the bottom. Notice when I do those fractions, I have proportional fractions, right? One is double the other. So I'm going to write that out just to kind of connect that dot, because this is connecting to the proportional idea. It's just not quite as easy to see at first. So the question is, what is the number that if I want to go from A to B, I would multiply each side by? That's what the scale factor is. So if I want to go from 18 to 9 or 30 to 15, the scale factor that I'm multiplying by is a half, or 0.5, right? I'm dividing by 2. In contrast, if I want to go from B to A and go from the 9 to the 18, when they say, what's the scale factor? They're just asking, what are you multiplying each pair of sides by? I am multiplying by 2 to double. Okay, so scale factors is kind of thinking about you're scaling a picture up or down. So that might be something useful to think about. We're scaling a picture up or down. Right? We're keeping it proportional to the original one. The sides have the same comparisons to each other, but we're making them all bigger. So obviously you can see I changed my mind and didn't want to do a problem just to keep the video appropriately length. So now you want to think about what kind of scale factors will make a picture grow or shrink or stay the same. So feel free to look back at the previous example with the two rectangles to think about what will happen with different scales. Okay, so double check which ones will shrink versus grow versus keep the same, right? Thinking about the example we looked at, we saw 1/2 and 2, and that's a good way to kind of think about being smaller than 1, larger than 1, or equal to 1. Okay, and these scale factors are really useful. Like if we think about the problems that we did before, like with the proportional giraffe problem here, if you think about that, you should have a scale, you're scaling it up, right? The 599 to get to 2000, there's a specific number that you're multiplying that by to obtain that amount. So there is a scale factor that's kind of embedded in that problem if you think about that. And so that's another way that we can think through these problems. Okay, so scaling things up and down does make them proportional. So it's a good way to kind of connect the ideas. This last one is a very typical kind of problem. A lot of times you'll see map problems where you have a scale, right? Scaling up or down. The map is representing real life, so that is scaling it up to represent real life. And 2 centimeters on the map are 160 miles in real life. So oftentimes I'll do, oops, let me get my pen a little bit smaller here. Oftentimes I'll do map to real life. So on the map, 2 centimeters represents 160 miles. And then we are looking at the distance between New Mexico going west through Albuquerque. It's about 4.1 centimeters. And we're going to think about what would that be in miles, okay? And there's a secondary question, but I'm going to look at that after. So let's see how many miles that is in real life. I'm going to do my cross multiplying, which says that 2 times x has to be the same as 160 multiplied by 4.1. Solving that equation makes x 328 miles. And there are your hours.